Lesson 67, I think, is fairly easy material. They're not getting in-depth with what they're going to be talking about today. But we're going to be talking about the introduction to transformations. And I've got the first couple of definitions already up here. Casey, can you tell me what a transformation is? Okay, change in position, size, or shape of a figure. All right, but overall its ratio is going to stay the same. Okay, it's going to maintain, we can transform it, we can do a lot of different things to it. And then we get into pre-image. What is a pre-image, Miss IL?
Original figure and transformation.
Okay, so we have to start with something. And when we're talking about figures, we're talking about two-dimensional shapes. Okay, it could be a circle, it could be a trapezoid, it could be a square, it could be a lot of different things, but we have to have something that we're starting with. Okay, so we're going to start with what is called the pre-image. Pre means that it comes before. Okay, all right, and then we have our next term here, which is image. Darian, what is an image? Okay, so it's what comes next after I have transformed it. Okay, which a lot of times we can get kind of confused, and so we want to make sure that we understand these definitions, because if it asks for something in particular about the image, it's not talking about what we started with, it's talking about what we ended up with. Okay? And there are different types of transformations. All right, so let's see. And if you're not familiar, if you don't know where we're at, you should be on page 445. Okay, if everybody's there, either in your book or in your ebook. And we've got a lot of stuff to talk about. So I'm going to try to type some of this while you guys are reading some of it. Okay, and this next one here is isometry. Isometry. Let's see. I need somebody to read this nice and loud. Aaron, can you do that for me? It's in the box.
It's a transformation that does not change the size or the shape of the figure. That is the image of an isometry is congruent to its pre-image.
Okay, an isometry is a transformation that does not change the size or the shape of the figure. And that's largely what we're going to be looking at today, are isometric transformations. It won't change the size or the shape. So if it was a square to begin with, we may change something, but it's still going to be a square. Okay? We may change something, but we're not going to change the size of the square. Okay, do you understand? Okay, if it was a trapezoid, it's still going to be a trapezoid that's going to have the exact same size and shape. That is what an isometry is. Okay? Let's see. That is the image of an isometry is congruent. Okay, and we should know what that term means. Congruent to its pre-image. Okay, so the image and the pre-image are the same. Okay, and you'll see off to the side there on page 445 a picture, okay, of two triangles. You've got triangle UVT, and you've got that as a pre-image and image UVT. Now, what I want you to notice here is some of the tick marks. I don't know if they're going to go through this. I don't think that they really talk about this too much. So let me draw this up here. Pre-image. Let's say triangle TUV. Looks just like that. Whenever they're talking about it, they're talking about triangle TUV. Now, if we're talking about an image of TUV, you'll notice something different about the labeling of it. Okay, is there anything missing from the labeling of image triangle TUV? Okay, it is this. Okay, it is these little apostrophe marks, meaning that T was my pre-image, my image is T with one tick mark. Okay, I have pre-image U. Okay, so my image is U with one tick mark. Okay, my pre-image was V, so my image is V with one tick mark. Okay? Now, we can do multiple transformations. Okay, we can go from my pre-image to an image, to an image, to an image, and every time we add another transformation, we add a tick mark. So if I have 2 tick marks, that means that that triangle has gone through 2 transformations. Okay? Do we understand that? And I can add, that tells me we've gone through 3 transformations. That means that there were 3 steps that got me from my pre-image to where I wound up at. Okay? Now, okay, so the terminology for that tick mark is prime. Okay? And so 1 tick mark means, this means T prime. Okay? U prime, V prime. Okay, so if I add a second tick mark, we actually call that T double prime. U double prime, V double prime. 3 is going to be triple prime, quadruple prime. Okay, those tick marks are actually called prime marks. Okay? Okay, that's my prime mark, and that's going to tell me how many transformations I've gone through. Because later on and in future lessons, we're going to talk about multiple transformations. Okay? All right. And I actually do refer to that in the sentence below this. Let's see. Mick, can you read that sentence below the box?
The small marks next to T, U, and V are primes, a symbol used to label the image in a transformation.
Okay. And if you didn't hear that on the recording, the small apostrophe marks next to T, U, and V are primes, a symbol used to label the image of a transformation. Okay. So let's go on to our next page, and let's talk about congruence transformation or rigid transformations. All right. And isometry is also called a congruence transformation. They're just giving you a different terminology for isometry or rigid transformation. There's 3 terms that all mean the same thing. Okay, isometry, congruence transformation, rigid transformation all mean the same thing. We want to notice that because if we get a question that says such and such about a rigid transformation or such and such about an isometry or such and such about a congruence transformation, right? We want to know that all 3 of those things are the same thing. They're 3 different terms for the same thing. Okay? Now, we're actually going to talk about some different transformations. Okay? Let's see. The first one is translation. Now, one of the things that often happens is because the word translation looks a lot like the word transformation, is that we'll tend to use those terms interchangeably, and they're not interchangeable. Now, we do use a different term to kind of separate it, and that is the word slide. Okay? Translation or slide. Okay? Let's see. Casey, can you read for me what a translation is? Okay. All right, so back to being able to do this directly. Let's say I took a triangle, A, B, C, and I wanted to translate it, okay? And I can move it up, down, side to side, diagonally, okay? But what's going to happen is that those are all going to move the same distance. Okay, so once I know what that distance is, I'm going to move everything the same distance. So let's say I'm moving it 10 to the right. Okay? Everything moves 10 to the right. And if I'm moving 10 to the right and 5 up, every point goes 10 to the right and 5 up, 10 to the right and 5 up, 10 to the right, and 5 up from where it started at. The biggest mistake I see with this is people will tend to take a translation and make it a reflection. Where, okay, I get B is up here, but then they'll put C here and A there. We're not flipping it. We're moving everything the same distance. Okay? And you'll notice that the orientation stays the same. B is on top. A is on the bottom left. C is on the bottom right. The orientation stays the same. Okay, we haven't spun anything. It's the same thing moving in parallel. Okay, do we follow that? We can get some heads wobbling up and down. Okay, I want to see that bobblehead action. Thank you. Okay, this is my slide. I don't know if you've been to a dance lately, but it's like always the same songs get played, you know. Cha-cha now, y'all. Okay, slide to the left, slide to the right. Okay, translation. Okay, you're still you. You didn't change in size. You just move parallel from where you were. Okay? All right, now you get that song stuck in your head. You're welcome. Okay. All right, let's talk about our next transformation. Our next transformation is going to be a reflection. A reflection. Matt, can you tell me about a reflection? Okay. Okay, such a line is a perpendicular bisector. Finish that sentence out for me again. Okay, now let me move that over here a little bit. Reflection. A transformation across the line such that the line is a perpendicular bisector of each segment joining each point in its image. Typically with this, we'll put this on a, go ahead and draw now for me. We'll put that on a coordinate plane. Okay, so let's kind of go back to our ABC triangle. Okay, ABC, where that is my pre-image. Now, I can reflect this across the x-axis, or I can reflect it across the y-axis, okay, where that's going to be a perpendicular bisector. So if I reflect this, okay, think of a mirror. Things are going to show up in opposite position. Okay, so if I reflect this just across here, I'm going to wind up with something that is going to change its orientation, right? So now this is A prime, C prime, and B prime, okay? Where this line right here is a perpendicular bisector. So whatever the distance was there, it should be the same distance on both sides of that axis, okay? C is going to be the same way. And B, the same thing, where these lines, okay, act as perpendicular bisectors across there. It's going to be the same distance across the line. Now this gets more and more confusing as we get more and more complicated reflection questions because the line of reflection is not always a simple x or y axis. Now we could flip it across the y axis and we're going to wind up with something like this where C prime is there. A prime is here, C winds up all the way over here, and B prime is there, but the distance across is going to be the same. Now, let me show you a more complicated one, because not that we'll see it today, but later on you will. What if my line of reflection is there? Okay, and my triangle is here. Well, then I'm going to have to go perpendicularly across, but I should still wind up with my triangle. Okay? But it's going to be a perpendicular line through here, so we're actually going to have to work with slope whenever we start doing that. Okay, so don't think that it's always going to be the x-axis or always the y-axis. We want to go back to that strict definition that a transformation across the line such that the line is a perpendicular bisector of each segment joining each point in its image. So what we want to do with this is we want to actually look at each individual point. We don't want to just eyeball it. Okay, do we understand what I'm saying there? Because when we eyeball it, that's when we tend to make mistakes. We don't end up with true reflections. We'll wind up with something that's too close to the line of reflection on the other side, where it's really close over here and really far apart. How many of you looked in a mirror this morning? I'm not making like a personal, like some of you, look like you didn't look in a mirror this morning. I probably look like that. Okay? Whenever I get, dressed and ready to go, it's like 5:30 in the morning. I try not to turn on any lights because I don't want to wake up the 3-year-old and the 1-year-old. So if I come in and I look a mess, it's probably because I didn't look in the mirror. But when you do, all right, you ever step closer to the mirror? What happens as you step closer to the mirror? What happens to your reflection? What does your reflection do? It gets closer to the mirror, right? What happens as you step away from the mirror? Okay, does it step an equal distance away from the mirror? Yeah, right? Okay, and that mirror is your line of reflection. No matter if you step to the right, it's stepping to the left, but you are still at a perpendicular line with your reflection across that line of reflection. Okay? It's going to do what you do, and it's not going to move that way. It's going to move this way, right? That mirror is always perpendicular with you. Okay? So, you ever watch like, some kind of crazy movie where, maybe a horror movie where somebody looks in the mirror and their reflection does something crazy? It's too far away or it's too close or it starts doing, like, that's not, it's creepy because it's not real, right? That's not how reflection works. Okay, so we're going to look at more and more examples, but because this is just an introduction to transformations, we're not talking about those more complicated situations today, but I do want you to be ready for that. All right, we've got another one, which is the last one that we're going to talk about today, which is called rotation. Sure. At rotation. Okay, rotation. Okay, rotation, and the other terminology for this is or turn. Okay, and I don't know that turn gives you a good view of this or not, but let's talk about it. Let's see, minor. Can I get you to read that? It should be on page 446. Okay. And sorry, it's sometimes hard for me to talk and type and listen at the same time. Okay. All right, so I think I've got that definition down. Is a transformation about a point of or center of rotation such that each point in its image are the same distance from that point and angles formed by a point, its image, and the point of rotation as the vertex are going to be congruent. So when we talked about translation or slide, everything moves the same number left, right, up, down. Okay? In a reflection, the important thing to know is our line of reflection. In rotation, what's important to know is our point and our direction of rotation. Because we can go clockwise or we can go counterclockwise around that point. Then we need to know the number of degrees that we're going. So rotation is by far the most complicated to work with. But again, for the most part, in this lesson, they're just going to ask you to identify what type of transformation is being done. We'll get into the more complicated aspects of this in future lessons where we talk about, hey, this is a translation lesson, or this is a reflection lesson, or this is a rotation lesson. All right, so let's see, I got to find a marker here. If this is my point of rotation, okay, and I have triangle A, B, C, and I want to go, 90 degrees around this point, what I'm going to end up with is I'm going to look at that slope and a distance and call that, okay, this is, that right there. Then I'm going to look, okay, I got this sky, I got that. Okay, I might get something like that, okay, where that is 90 degrees, okay, about a point of rotation going clockwise. Okay, so there's a lot of different aspects to it. All right. That, I think, gets through those notes. Let's see if I can pull up what we actually want to cover today. Let's see, we're at lesson 67. Is that right? Okay. Like I said, I'm a little bit of a mess today, trying to catch up. Okay, like I said, mainly what we're looking at here is what type of transformation are we working with. Which type of transformation takes this A, B, C, D, right? How can I tell that this figure right here is my pre-image? How can I tell? Doesn't have any prime marks, right? So what is taking me from here to here? What type of transformation? Am I sliding it? No, I'm rotating it. And if we were to pick a point of rotation, we would say point D is probably the point of rotation. Okay, it is the vertex by which I'm, rotating this. If we wanted to be more specific, we could probably say it's about a 90 degree, or probably greater than 90 degree, because what you're going to see, notice that the angle between C and C prime is greater than 90 degrees. Okay, so it probably has a little over, we could say it has 180 degree, or sorry, not 180, but 100 degrees of rotation about point D going counterclockwise, right? We could get some more information out of that if that's what they were looking for. Does everybody understand that? Okay? All right. 2. All right. What type of transformation are we getting here? Erica, what do you think? Is this a translation, a reflection, or a rotation? What do you think? Translation, because it looks like I'm sliding it, right? I'm going from here to here. That's a simple slide. Notice that the orientation hasn't changed. Now, in a rotation, the orientation will change, and in a reflection, the orientation will change. That's one of the clues that it's a translation, is that it's in the same position. Okay? J is down here, so J is right there. F, F, G, G, H, H. Nothing has changed order as I go around. Okay? So that's one of the things I want to look for if I think I might have a translation on my hands. All right. Now, what is this? Is that a translation? Mick, what do you think? Why do you think it's none of those? Exactly. Perfect. Because in a translation, a reflection, or rotation, they're all isometric, right? They're rigid. They're congruent transformations. Are these two shapes congruent? No. This is going to get into something that we'll look at later. This is a dilation. A dilation will change the scale. Okay, it'll be similar but not equal. So your answer on 3 is D. Okay? Let's come over to 4. Austin, what do you think? Is it a translation, rotation, reflection, or none? Rotation, okay? All right, so I have this figure right here. And do we know what our point of rotation would be? Anybody know? Point B. Point B is my point of rotation. Anybody have any ideas about the degrees of rotation? Perfect, 180 degrees, because you'll notice that those are right across from each other, which create a straight line. So it's 180 degrees from there to there, or we could go around the other way, right? Okay. Right, two 90-degree angles. Okay, so it's 180 degrees of rotation about point B. I'm trying to give you the idea that later on, we're going to be working with more information than what we're working with today. Okay? All right, 5. Okay, this one I'm not, we'll do this. All right, does anybody want to come up and actually show me if my line of reflection is DE? Anybody want to try to draw? Okay, Brady? I'm going to reflect across line DE. That's fine. Okay, perfect. I mean, for the most part, maybe not perfect, but pretty good. Okay, so what you're trying to do is you're trying to, now, what would I call that? Do I need to do anything to that C? Prime it. Let's put a, all right. What is this point right here? B prime. And what about this point right here? A prime. And so what we should be saying is that, and this is also D prime, and this is E prime, right? Okay, and what we're trying to accomplish here is that this should be perpendicular, right? This should be perpendicular. That should be perpendicular, correct? Right, because it should be a perpendicular line across the line of reflection where these distances are the same. Right, does that make sense? Okay, you're trying to draw them straight across that line of reflection. Okay, so that's the kind of picture we want to get out of that. Let's see. Caleb, what type of transformation is being done here on 6? What's that? Rotation. Okay, so we have a rotation. All right, what is the point of rotation? Do you know? Okay, so we would say rotation about point F. Okay, do you know the direction of rotation? Clockwise. So I'm going to put that in here. Rotation clockwise about point F. Again, that's more information than what they're asking for. At least I think so. Let's see if they include any of that. Okay. Triangle DEF is rotated clockwise about point F. We got one final one to look at, and then you guys can get started. Identify the type of transformation illustrated here. Let's see, Miss IL, what type of transformation is that? Okay, and it's a translation of which direction? To the right? Think about that a little bit more. What's my pre-image? Is it the one that's up and to the left or down and to the right? Which one am I starting with? The one on the right. So how am I getting A to A prime? What's that? I'm going to the left. Okay? So I'm going there, right? And then what? Up. So I'm going left and up. Okay? So it is a translation left and up. Okay, and I should go the same distance left and up to get to all three of those points. Okay? All right. You have all your information in your classroom, should have all your numbers, right? And I'm going to put this video up so you can go back and watch it if you need to. Okay.